Welcome to another edition of Quarantine Science with Mr. Aldhouse. We are in week number 4. It is a Friday. It is a beautiful day outside. The sun is shining, the grass is green, the sky is blue, there's no clouds in the sky. It's amazing. Beautiful day today, so I strongly encourage you to get out there and enjoy that. Today, my students, first I want to just tell you, you're doing an awesome job. Keep up the hard work. You guys are killing it right now with this e-learning schedule that we have. The work you're producing is incredible. Keep working hard. I love it. Absolutely love it. So keep up that good hard work. Today we're going to dive into transition metals. We're going to be looking at a couple things when it comes to transition metals. We're going to be looking at their location on the periodic table. We'll briefly give you a couple of examples of those. And then what we're going to spend the majority of our time on today is looking into what makes them so unique when it comes to naming. Why do we have to name them a little bit different than we do our regular ionic bonds? So when they ionically bond, when a metal bonds with a non-metal, and transition metals are no different. They're going to bond with non-metals. They're going to create ionic bonds. So when that happens, why do we have to name them a specific way? Why can't we just use our old rules? So let's go ahead and jump right into it. First of all, location on the periodic table. They're going to be in that middle section, columns, or I guess you would say families. 3 through 12. You're going to look at examples are like iron, you're going to look at nickel, you're going to look at carbon. Of course, you're going to have titanium in there. You're going to have a lot of different examples within those periodic or within those transition metals. Nickel, copper, all transition metals. So what makes them so different when it comes to bonding? Why do we have to treat them so differently when it comes to bonding? Well, the biggest thing is this. They can take on different forms of an ionic bond. So what they can do is their charges can vary. You can have iron 1 positive. You can have iron 2 positive. You could have iron 3 positive, okay? So they don't follow those rules of the other families. They're not like an alkaline earth metal or a alkali metal. They're not like those that follow those specific rules where it either has to be 1 positive if it's in this column or 2 positive if it's in this column. They can kind of form different ways ionically. They form those different charges. So if we look at, for example, iron, okay? We look at iron. Now, when we look at iron, you know that this is iron. This is the symbol for iron right here, okay? So when we look at those things, we know that ionic forms of iron, all right, when it makes its ionization, when it turns into its charge, it's going to want to go positive, okay? So we look at iron. Iron can go a couple different ways. Iron can be just regular old iron. You'll see it written like this. Sometimes, if it's positive, you put your positive there, okay? Some people like to put this right here. The Roman numeral 1 represents the charge of the iron atom. Okay, of the iron ion. So that 1 right there represents iron 1 positive. Okay, you'll see it written that way. You don't always have to write it that way. It's completely up to you. But anything above 1, okay, you're definitely going to want to put those Roman numerals in there. So if I'm looking at it this way, let's go ahead and erase this here. And let's say we have iron that has a ionic charge of 3 positive. Okay, so we have iron with an ionic charge of 3 positive. To write that, all I have to do is put a parentheses, Roman numeral 3. Iron 3 positive. Iron 3 positive. And it doesn't matter what number you're using. You could put a 2 right here, 2 positive. And all we do is go up here and take one of those away, and now we have iron 2 positive. So the Roman numeral gives us the charge. This right here shows us that. And then vice versa. If I have the charge and I don't have the name, I go up here. Okay? So that's how we write out the ionization form of iron or any, I mean, you could put cobalt there, you could put nickel there, it doesn't really matter. Any transition metal is going to be written out this way. Now, when we have a formula, okay, when we're writing a formula, so say, for example, let's use cobalt, okay? So we're going to use cobalt. So let's go cobalt and fluorine, okay? So if I have cobalt, CO, okay, and I have fluorine, which is an F, and let's say that we have 2 fluorine atoms, okay? So COF2, okay, COF2. What do we know? Well, I know in this situation, this F carries a negative charge. One of the earlier videos that I showed laid it out like this. I'm going to show you that again, and then I'm going to show you the way that I prefer to do it and the way that I think you're going to prefer to do it also. So I know I have two F's. All right, I see my two F's right there. I put my F, negative, F, negative. Why is the F negative there? Why is it? Because that's the number, that's the ionic charge that it wants to take in. All right, well, it's a non-metal. It has 7 valence electrons, so it wants to take in one of the electrons. And then I have cobalt over here, so CO. I don't know what this charge is yet, but I do know that whatever the charge of this is, it has to equal the charge of this. So I have 1, 2 negatives. Well, if I have 2 negatives over here, then this has to be what? 2 positive. Okay? So when I write out the name of this bond right here, cobalt and fluorine, CO 2 positive 2F. Okay? So when I write this, when I write it out, what I want to do with this, I got my cobalt, so I'm going to write cobalt. And then what was our charge of our cobalt? Well, let's go back and look. The charge of the cobalt was 2 positive. So I put my Roman numeral 2 in there. So put my Roman numeral 2. And then fluorine. And actually it would be fluoride. Because we remember we always drop and add the IDE. So cobalt to fluoride is how I would write out that transition metal. Okay, pretty straightforward. You can go through and do it this way if you want and drop down, and that's fine. I got a better way that I would like to show you. We're actually going to up the ante and give you a little bit more difficult one. Okay, so what if I give you this example? What if I give you CO 2 S 3? All right, so there's our example. CO2S3, okay? Cobalt and sulfur. Transition metal, non-metal, ionically bonding. Well, as you remember from class, in third period we even made a little sweet little dance. Remember that? The cross and drop? Yeah, we're going to cross and drop it. Drop it like it's hot right now. Cross and drop it like it's hot right now. So what we're going to do is, instead of crossing and dropping though, we're going to go back up. Okay? So I look at this. All right, I'm going to grab this red marker from back here. I look at this, and we know from crossing and dropping, we can take charges and drop them down, correct? We know how to do that. And we also know that we can send them back up. So what I'm going to do is I'm going to take this 2 right here and send it back up. And that gives me the charge of the sulfur, okay? I'm going to take this 3 right here and send it back up. And what does that give me? Well, it gives me the charge of the cobalt. So when I go to write it out, I have the charges now, okay? My cobalt charge is CO, up, send it, 3 positive. My sulfur charge is S, send it up there, 2 negative. Now you can easily write out the name. It would be cobalt 3 sulfide. So let's go ahead and write that out. So cobalt, parentheses, 3 sulfide. Straightforward, simple, and easy. This represents the charge of the cobalt, and then the sulfide obviously is the non-metal of the ionic bond. We drop the end, add the IDE, and you're good to go. Now, what if I get an example like this? Okay? What if I get an example like this? Iron, okay, 3 oxide. Okay, so there's our example. I'll show it to you one more time. Iron 3 oxide. Again, this represents the charge of the iron. So write it in there, okay? Make your Fe, and I know what the charge is. It's telling me 3, okay? So put your 3 positive there. The oxygen. Do we know what the charge of the oxygen is? Of course we do, okay? It's 2 positive. Ionization form is going to be 2 positive. It's always going to be 2 positive. So put my O, 2, 2 negative. Oops, 2 negative. O2 negative. Okay? Charge of the ion, charge of the oxygen. Again, We drop it, cross it, drop it like a ton. Take this, drop it down here. Take this, drop it down here. Okay? And what that's going to give me is that's going to give me my formula for iron 3 oxide. It is Fe 2O3. Okay? So when I put it all together, I look at it here, iron 3 oxide. This 3 right here is telling me what the charge of this iron is. So go ahead and write them out. We know our oxygen is 2 negative. It always is. Cross them and drop them. Okay? That will give us the subscripts for the formula. So when I cross and drop and get the subscripts for the formula, that's what I end up with. Okay? If you have any questions, please don't hesitate to email me. Let me know. Hit me up on Schoology. If it's actually working, which it usually isn't, no bueno. It has been bad. But hit me up on Schoology if you need to. Email me if you need to. Hopefully those things are working. If you have any questions at all, let me know. Go through today's agenda online. See if you have any questions. Make sure you do the exit ticket. That's one thing I do. I want to make sure that we're all kind of on the same page going forward. So make sure you do the exit ticket. The bonding practice is just helpful practice. Guys, remember, it's just like class. I don't need you to do every single one. Pick a few out. If you can do them, move on and go. Don't kill yourself. Don't waste your time doing a bunch of things that you already know how to do. If you got it, go. Move on to the next piece. But I do want to make sure that you're doing that exit ticket today. Other than that, ladies and gentlemen, we have successfully maneuvered through naming bonds, and we've done it online. That's amazing. Okay, this is a difficult topic. If you need extra help, you want to jump into a Google Meet sometime and meet with me, let me know. But guys, great work today. Hopefully you like the new little fancy intro that I got. I'm working with a couple people right now to see if we can up that ante a little bit and make this a little bit more worthwhile for you. So keep up the great work. Awesome. Have a great Friday. Enjoy. Ladies and gentlemen, I'm out. I hope to see you all soon.